profiling. For example, we have these tested compounds, and these are activity, and then we can predict their activity for new targets. So here we have new targets, and then these are the protein targets, and we can predict whether these compounds are going to have activity for these new targets on board. So that is one application of QSAR. And then it is also being used extensively in synthetic organic chemistry. So we generate a target molecule. Is it easy to synthesize or how to make? We can use QSAR for that. We use starting material as information. We move forward. We design a target molecule, and then we go backward, like we do retrosynthesis. So all these questions, like how to proceed with this reaction, or how to get optimal conditions, or how to make the reaction efficient. So all these can be used. QSAR can be used in all these studies actually. And then we have in quantum chemistry also, we can nowadays people are doing density function theory, DFT calculations using QSAR models. So that is also an important application of QSAR. And then in material informatics, there is a lot of opportunities people are doing. People are trying to explore new materials using QSAR modeling. Okay. And then is the nanomaterial informatics. People are trying to there are a lot of nanomaterials like micelles, quantum dot, dendrimers, carbon nanotubes, metal oxides. So people are trying to explore or determine their properties using QSAR modeling. So it is called as quantitative nanoparticle activity relationship based modeling of nanomaterials. And since nanomaterials differ from the chemical compounds, so the molecular descriptors which we use in normal QSAR modeling for chemical compounds is different from what we use for nanomaterials actually. I skipped this one for the sake of time, this one as well. Yeah, so I come to the main topic, that is challenges in QSAR modeling. So how or what are the problems which exist in QSAR modeling, and we need to take care of them. What can be those things? So the first thing is failure to take account of data heterogeneity. So, whenever we are trying to curate the data, so we look for a paper, and then we cannot find maybe more than 10 compounds or 20 compounds in a paper. So we take 5 different publications and we collect molecules from those publications. But most of the times we skip the details about their biological activity. Like, for example, in one paper, they might have used one method to determine the activity. In another paper, they might have used another method to determine the activity. So in QSAR, we cannot combine data from different assays. Ideally, we should use only compounds which are being tested in the same laboratory by the same method, by the same person. So that is the ideal situation. But even if it is from other laboratories, but still, if we have it from the same method, that will be just fine actually. Okay, so because if we are getting data from different species or different protocols, so we cannot combine that, and that will be of no use actually. The similar thing is with physicochemical data like aqueous solubility. So we try to curate data on aqueous solubility, but maybe one person in one laboratory, they have done aqueous solubility in simply water. Someone else has done it at a specific pH, like at pH 6.5. Someone has done it in the buffer. Okay, so all those different properties coming from different methods, different protocols, those we need to take care of, and it is very, very important. As I said, like garbage in, garbage out, so that should not happen. So we should spend more than 50% of our time on data curation. And then the use of inappropriate endpoint units, like concentration should be expressed in molar units, not in weight units like moles per kg, not milligram per kg. So this should be the ideal situation, moles per kg. And then percentage response at a fixed dose is not a good data for developing QSAR models. So that we need to keep in mind. And then use of confounded descriptors, like there are some highly collinear descriptors which contributes the same information twice, and that makes it that makes the QSR model overtrained, we can say, or of no use. So we need to filter out those confounded descriptors, the descriptors which are auto-correlated with each other. And then use of non-interpretable descriptors is also one of the problem. So people sometimes they are using fancy descriptors, but those descriptors, they cannot explain the mechanism of action of those compounds. Okay, so then error in descriptor value. So that is another problem. So like for example, 4-nitrophenol. So 4-nitrophenol has 7 measured log P values, and that ranges from 0.76 to 2.08. So which one would you consider the true one? Okay, so if for example 7 different people are using those 7 different values, and this is measured, actually this is not calculated, this is measured log P. So if 7 people are using those 7 different values starting from 0.76 to 2.08, so those will be getting different results, right? So that we have to take care of. And then 7 log P values calculated from VCC lab software ranges from 1.35 to 1.93. So if it is calculated, then it is ranging from 1.35 to 1.93. And poor transferability of QSR is another problem. So lateral validation of QSR model is important. Lateral validation means like we have validated it by using one method, then we have to validate it using another method. So that we have to do actually. And transferability, reproducible descriptor values, these are all some issues. And then we have inadequate or undefined applicability domain. So we do not know whether the response and chemical structure space in which the model make predictions with a given reliability, and test chemicals must be similar to training data set actually. And unacknowledged omission of data points. So we have like 15 data points, and we without any explanation, if we remove 5 data points just to increase the value of R square in our QSR model, that is also not good actually. And then we have use of inadequate data. So use of incorrect, misspelled or insufficiently defined chemical names, incorrect case number and incorrect structures. For example, chlorooxylenol and 4-chlorocresol are among the chemicals which are examined. So chlorooxylenol has 18 structural isomers and 4-chlorocresol has 2 structural isomers. So out of those 18 structural isomers of chlorooxylenol, so which one to use? That is a question of interest actually, and that is important as well. Again, replication of chemicals in data set is important issue. So desalting leads to replication if not performed properly. So we have to take care that desalting is done, and those replicating structures are also removed. Narrow range point of endpoint value is also another problem. So they should at least have 1 log unit spread in their biological activity. And obviously overfitting is a big issue. So if we are using simple linear regression, so the ratio between training set and descriptor should be 5:1. And overfitting can be a problem with use of non-linear techniques such as artificial neural network. That is a major issue. And okay, yeah, and then opposite to that, use of excessive numbers of descriptors in a QSR is also a problem. Like if we are using a lot of descriptors to define the activity, that might be really problematic. So one way is to just use some kind of method to reduce the number of descriptors. And then inadequate or missing statistic measure like correlation and correlation coefficient, standard error estimate, adjusted determination coefficient, internally cross-validated R square. So I think these are the basic statistics which we need to have for a QSR model, but we can go beyond that as well. Incorrect calculation have been published at large scale. Yesterday only I was like reading paper, and a tweet actually. So he said that one person he read a paper, and then he found that it was about deep learning QSR model and giving a correlation coefficient of the value of 0.8, and then he said that when he looked at the data, So that data contained almost 100 duplicate structures. So 100 duplicate structures means like those duplicate structures are contributing positively to the model actually, because those are repeated information, right? So those kind of data are published at large scale, but we need to be careful in that. And then lack of descriptor auto scaling is also another issue. It is highly recommended to determine the relative contribution if each descriptor. मुन्ना सिंह कुछ कह रहे हैं क्या? Yeah, okay. So the important thing which I wanted to say is that data curation is one of the most important thing. So the workflow, like how it should go, is like we first remove the mixtures, inorganics, and eventually organometallics from a data set, and then the structure should be converted, cleaned, and the salt should be removed. And normalization of the specific chemotype should be done, and treatment of tautomeric forms should be done. And then after that, removal of structure duplicate should be done. And then we should have inspected the data manually in order to obtain a nice data. So you can see that the color goes from red to green, means that we are going in the right direction. So then we will get the curated data set. This curated data set then should be used for making QSR model, or even for other COMChem methods as well. And then next step is to generate the descriptors, molecular descriptors, and then we split those molecular descriptors into training set and test set, and the test set contains a internal validation set and external validation set. And then we use machine learning models to develop machine learning methods to develop models. And then those models should be carefully selected on the basis of their internal and external accuracy and the statistic. And then in the end, we should also assess the applicability domain, like what kind of chemical structures we can predict with this specific QSR model. Okay. So I can give you some examples of data curation. For example, if we want to remove, we get some compounds like this quinine sulfate dihydrate. So we have to remove this inorganic part out of this molecule. So for example, in our data set, we have two compounds. One is quinine, plain quinine, and then we have quinine sulfate dihydrate. Okay, and once we remove quinine is fine when we are processing these compounds. So quinine is fine, but if we are removing this salt from quinine sulfate dihydrate, so then we are getting another quinine in the data set. So now we have a duplicate structure. So we have two quinine in this data set. So those we need to remove. Otherwise, this data will be leading to false predictions actually. The same is with pyridostigmine bromide, for example. We need to remove this bromine or phenoprofen sodium. Okay, and then there are some organometallic compounds which are containing both organic compounds, organic moieties, and both metals as well. Like this contains magnesium and sodium. So in this case, we have different tools to develop or generate descriptors. Like we have Dragon, it will not handle organometallics. We have MOE, molecular operating environment, which is another tool. So it can be used to calculate the descriptors. ICDA is another one, HIT QSR is another one. So if we are not able to calculate descriptors with one method, we can always use another method actually. So there are several alternate methods which are available. And structure conversion and cleaning is important, as I said. So there are several tools like Amexon, MOE, Sibyl, OpenBabel, and then we can use Smiles as input format. We can use that one as well. And then the neutralization of charged organic molecules is more disputable because we don't know which is the bioactive form. For example, if we have an acid, carboxylic acid, so we don't know whether the ionized form of carboxylic acid or the unionized form is the biological active state. So in that case, the suggestion is that we keep both unionized and ionized, but generally we remove the charges because most of the molecular descriptor calculation processes, they don't handle charged molecules actually. And then also we need to normalization of the specific chemotypes. So the same functional group may be represented by different structural patterns in a given data set. So those we need to see whether we are contributing positive information in that or not. One example is this nitrobenzene, sorry. So in this case, you can see that this nitro group can exist in 5 different states actually. So which one is the best? Which one is the correct one? So that is a $1 million question, I think. So it indicates that even small differences in structural representation that leads to significant changes or errors in predictive ability of models. So we need to be really careful about that actually. And then we need to again removal of duplicates. Yeah. And then there are several automated tools which can be used to remove the duplicates, like ICDI is one. And then detection and verification of activity cliff. So, you know, we have the compound A, for example, active, and if it is having very similarity with another compound B, which is active, so we can, on the basis of this decision tree, we can define the activity cliff of the molecules, those molecules. And in the end, there is the most important thing is final manual checking. So if we have done all those data curation and preparation carefully, so we have to check those molecules manually to see that we did not get wrong at any place actually, especially its charge or explicit hydrogens or incorrect bonds. Yeah, so this is just a summary, like, starting from 17143 compounds. After all those steps, remove inorganic, structure conversion, normalization of chemotypes, treatment of tautomeric forms, removal of duplicates, manual inspection, we get 16142 compounds. Yeah, and this is last slide. Thank you so much. Yeah, and if you have time, so I would like to play a short quiz actually. So those of you who are attending it from their laptop, and they have their mobile with you, so they can participate in it. What do you think, sir? Professor Chandra?
Hi, you can, sir.
Yeah. So then I would like to ask. I stopped sharing this. Yeah, but before that, if any one of you have any question, then I'm happy to answer. Maybe it might be that you. Yeah, so if you have any question, yeah, I'm happy to answer it. And then we will have this short quiz.
Anybody?
Okay, no worries. So I stopped sharing this. And I share another screen, a tab. Yeah, so I place. Yeah, so what so the ones who are using their laptop, so they can open this website on their mobile, kahoot.it, and enter this pin to enter into this quiz actually, and then we start. So what you have to do is you have to take out your mobile from your pocket, and then you just type this www.kahoot.it into that, and then it will show you join. So you enter this pin 1955618, and then you will be here as a player in this quiz. And then when I start, you will see the question on this screen, and from your mobile you have to answer that. So I think that's a real-time kind of quiz in interactive way that you can use it for your students as well. Okay, no one is interested in this as well?
Actually, most of the participants are joining by their phone.
Okay,
I
good. So
think
we have
that's
got
why.
one player. Yeah, so the name will be like random, so you
Your
don't
nickname
bother
is
that your name will be displayed here and if you answer it or not.
they're showing your nickname is. You have to spin it.
Dr. Prashant Upadhyay, you want saying
Yes,
something?
they have opened the.
Dr. Prashant, are you saying something?
Sir, I'm repeating the what I am seeing on the net. Now your nickname is. Oh, I have spinned it. Please continue.
Yeah, we got two players. Yeah, a couple of more and then we start. Okay, that one left actually.
Great Yeti.
Okay, a couple of more. Please come on. Dr. Pranav, you can. Dr. Uday Veer Singh, Achad Danish. Okay, I think we are good to go actually. So we have how many? Six players.
Six.
Okay, let us start then. So I press start and then you will see the quiz. Yeah, so here is question
Loading.
number one, which is true or false. So you have 30. You have got 30 seconds to answer it. QSR helps in creating models, which helps predict biological activity of a compound using properties like IC50 and KI. So either true or false. So it is like, yeah, I just created it for fun actually. So it's very simple quiz. Yeah, so we got three answers. And the melodic well is on the top. Next question is QSR uses already available data to make models using predictive algorithms. What do you think? Good. This time I got really good answers. Yeah, so 5 versus 1. So it says that this was the correct answer. This was wrong. So 5 people they answered it correctly.
Third question.
Next one, large change in biological activity with small change in structure. Which of the term best denotes the statement? Yeah, we recently saw it. Come on, we only have 5 seconds. 4, 3. Okay. Oh, there is only one correct answer actually. No problems. So we come to the next question. External test set and time split test set are some multitask modeling methods. Is it true or false? 16, 15 seconds to go.
True.
DNN, KNN, and partial PLS are some of the machine learning based methods. True or false? Okay, so I end this game actually because so we have got 5 questions. So in the end, we can see
Third place.
the results actually. So who has got most correct answers?
Yeah. First.
Amazon Sloth is the one who got 4 questions correct out of 5, and then Great Yeti and Study Pony were like two of them. So I think this was just for fun, and I think you can, if you feel that it can be used for teaching your students as well. So then I'm really happy about that. So I stop it. And again, I would like to say thanks to Professor Sushil Kumar and Professor P. Chandra. So they contacted me, and I was fortunate to deliver this talk. Thank you so much.
Thank you so much, sir, for this knowledgeable lecture. I would like to thank all the participants for joining today's session. We will resume tomorrow evening at 3:30 p.m. with another knowledgeable lecture by Dr. Ajay Samalti, University Swayam Coordinator, HNB Central University, Srinagar, Garhwal, India. See you all tomorrow. Thank you.
Thank you, Rajni sir, for your nice informative session for our participants. Thanks a lot for you.
Yeah, thank you, sir. Bye.
Thanks, sir.
Take care.
Thank you.